Imagine this traveller of the silent cosmos. You arrive on a night when an interstellar fragment brushes past our star, slipping between Mars and the Sun, where no telescope on Earth can truly see. Astronomers have waited years for this single moment. The day 3 Atlas reached Perihelion, the day the numbers were supposed to make sense. But instead of a smooth brightening, there were 3 uneven pulses of light, each separated by exactly 0.7 hours. A rhythm where there should have been silence. What if this wasn't a mistake in our models, but a decision? What are the odds it happened just as you pressed play, stay a while, traveller, listener, traveller, quiet observer beneath a sleeping sky? Imagine a night still waiting in the future. A night when our telescopes turn toward the sun, not in fear but in curiosity, listening for a small cold visitor gliding through the inner system. On that night, the story begins with the simplest clue: the way its light changes. Across continents, instruments hum softly. In deserts, on mountaintops, in orbit, they all watch the same wandering point. 3i Atlas, an interstellar fragment threading a path between our star and our scattered worlds. They measure its luminosity profile, that gentle rise and fall of brightness, as photons bounce from its surface and drift into our mirrors. The models are ready long before the light arrives. Rotation rate, albedo, estimated size, gravity and thermal physics all folded into clean lines on a screen. The curve should crest smoothly, then fade as the object slips behind solar glare. Elegant, predictable, comfortable. But when the photons finally reach us, the curve does something else. Instead of a smooth hill of light, the record shows broken steps, a jagged pattern. 3 spikes of brightness, unevenly spaced, separated by brief moments of near darkness. Bright, dim, bright again, then dim once more, as if the object were breathing in slow metallic sighs. In observatories scattered thousands of kilometers apart, analysts blink at the same shape. It must be a calibration error, they think. Solar noise, saturated sensors, a trick of scattered light. They adjust parameters, clear caches, run checks. Yet the strange rhythm remains. Every 0.97 hours, almost exactly, the light swells and falls, a heartbeat written in photons. Tonight the universe whispers again. The same pulse appears in data from dry highlands, from island peaks, from a spacecraft suspended far from Earth. Different mirrors, different detectors, one repeating rhythm. This is not random. This is not the usual chaos of dust and ice boiling under sunlight. Normally a comet near the sun grows wild. Its coma swirls, bright knots bloom, and fade jets roar and sputter. The light is turbulent like steam from boiling water. But here the brightness seems to gather itself, then release, as if the surface is choosing when to shine. Some astronomers describe it as non-random reflectivity. Others whisper another phrase: controlled phase oscillation. For you, traveller, these are just words. But beneath them is a simple image. A small body turning in the dark, adjusting the way it reflects light, as though testing how much of itself to show. At the height of each pulse, 3i Atlas reflects about 12% more sunlight than before. In human life, 12% may not sound like much. In the quiet math of space, it is a raised eyebrow. A jump that happens not over hours but almost at once, like a mirror suddenly tilted by an unseen hand. And so the first question rises gentle and unsettling. Is the object rotating differently, or is something on it moving of its own accord? The rotation parameters, when re-examined, are not quite where we left them. The spin period has shortened by a few seconds. A tiny change for human clocks. A meaningful change for an object moving nearly 100 kilometers every second through starlight and solar wind. Some researchers note that this shift in spin lines up nearly perfectly with the brightness peaks, as if the way it turns and the way it shines are parts of the same quiet decision. As if it is stabilizing itself, not just enduring gravity, but responding to it. Skeptics, calm and necessary, remind us of dust jets, of uneven outgassing, of cracks in ice that breathe in sudden bursts. Nature can be strange enough without our dreams added in. They are right to say it. It's all right to not understand. Yet even as caution speaks, the anomalies continue to stack like faint stars in a long exposure. The last of the 3 brightness peaks arrives not when the object is nearest the sun, but after. It is already moving outward into cooler space, into regions where we expect light to soften and fade. Instead, it flares again, and this time the glow doesn't come from the sunlit face, it comes from the dark side. For a moment, somewhere between solar fire and interstellar night, the shadowed hemisphere shines. Not with borrowed sunlight, but with something else. Some observatories see a narrow spike in the infrared near a wavelength that suggests heated metal rather than thawing ice. The data is quiet, but it is firm. A whisper, not a shout, but one that will not quite go away. In control rooms lit by monitors and coffee steam, someone writes a short note, possible artificial reflectivity event pending confirmation. It does not go into any press release. It does not make a headline. It simply exists as a line in a log, a small human attempt to name something that might be impossible. Meanwhile, far from official statements, amateur observers compare their frames. They notice the flicker, the beat, the pulse. A light that blinked once and was gone, then again, and again. The pattern spreads across message boards and late-night chats, drifting between curiosity and sleep. You, listener, are part of that same pattern now. You are not lost in space, you are part of it. Because every time we notice an anomaly, every time a graph refuses to lie flat, the universe is gently rearranging our expectations. It is teaching us very slowly that certainty is only temporary, that the cosmos is older than our models, and sometimes it answers our equations with a soft, sustained no. Tonight the numbers are not simply wrong, they're different. They are pointing towards something we do not yet have language for. Somewhere beyond our reach, something ancient still moves. Perhaps it's only rock and ice caught in a geometry we have not yet mapped. Perhaps it is just an intricate accident of thermal physics. Perhaps it is nothing more than chaos briefly mistaken for intent by tired eyes at 3 a.m. Or perhaps it is a reminder that light curves are not just data. They are stories too. Stories of how matter scatters photons. Stories of how gravity bends motion. Stories of how a small object crossing a star's hot breath can make us question what it means to be alive or inert or somewhere in between. For now, observer, the only honest answer is this: we do not know. Some mysteries aren't meant to be solved, only observed. And that is enough for tonight. Let the graphs rest on their screens. Let the telescopes hum softly in their domes. The object continues on its path with or without our understanding. Its pulses fade into the background hum of the solar wind. The sky remains vast, indifferent, and strangely comforting. Sleep now, observer. The cosmos will keep watch. Traveller of the quiet heavens, the night has not ended. The sky holds its breath, and the sensors of Earth continue their patient work, collecting light from an object that glows when it should fade. Every telescope, every lens, every mirror tilted toward the sun is waiting for the same truth. Yet the truth keeps changing its shape. In the models that live on our computers, and in the minds of scientists, a comet near the sun is simple. Sunlight touches ice, the ice turns to gas. The body brightens for a while and then cools, releasing a steady breath of dust into the solar wind. The curve is graceful, a soft hill of heat rising and falling, guided by the laws of thermodynamics. For decades, that rhythm has been enough to explain everything we have seen. But 3i Atlas refuses to sing in key. Its temperature does not follow the curve we expect. It moves in uneven waves, rising and falling as if something within it is stirring. The infrared readings from our orbiters tell of oscillations, heat swelling, dropping then swelling again, matching perfectly with the pulses of light recorded earlier. It is a rhythm almost musical, repeating with precision. Objects made of ice and rock are not supposed to do that. They warm when the sun commands them to, and cool only when distance allows. Yet here the warmth drifts from one hemisphere to another like a whisper between two minds. Parker Solar Probe. The small craft sailing close to the sun sends back its confusion in numbers. During the moment when the comet should be at its hottest, one of its sensors records a sudden dip, a loss of infrared brightness nearly 20% below the model. The only way for that to happen is if the surface of the object reflects heat instead of absorbing it. It is the thermal equivalent of watching a snowflake survive a flame. The scientists read the data again, hoping for a mistake, but the line remains a clear notch in the curve, the signature of a surface that behaves as if it has a choice. In a quiet report, someone writes the words, high emissivity control. Another writes metallic reflectors, and then softly, not natural dust. Still no one says the impossible word, not yet. The solar orbiter, following its own elliptical path, sees something even stranger. Around the object's trailing edge, the ultraviolet spectrum flickers. A short bright shimmer appears not white, but violet blue, the signature of metals heated until they shed their electrons. Nickel, cobalt, a trace of molybdenum. These are not the gentle minerals of a drifting comet. They are the industrial elements of stars' reborn metals that once melted in furnaces older than Earth itself. At first, scientists blame the sun. Perhaps it is an echo from the corona, they say, light scattered by plasma, a mirage of intensity. But the chemical ratios do not match. The sun's light carries no such fingerprint. Whatever shines within 3I Atlas, it carries its own spectrum. To some, it is an artifact of coincidence. To others, it is the sound of design. The heat data becomes more intimate as the hours pass. When the object faces the sun, it glows with measured calm, 480. Kelvin steady and predictable. But when the solar orbiter views the opposite hemisphere, the temperature doubles. 960 Kelvin, hotter than molten glass. Hotter than we thought it could survive. Yet there is no disintegration, no spray of dust, no change in motion, only balance. A phrase appears in the internal memo's thermal phase inversion. It means an object that radiates more energy than it absorbs. For something without an internal power source, that should be impossible. For a living system, it would mean metabolism, the transformation of energy into function. The term disappears quietly from later drafts, replaced by the safer words irregular heat redistribution. But the numbers remain. In the data's soft hum, a pattern begins to whisper through the noise. The oscillations repeat every 52 minutes, the same interval as the light pulses that came before, the same rhythm that made the stars blink in our telescopes. This time, though, the music is thermal, a heartbeat not of photons, but of warmth. And with each pulse, the comet exhales. Jets of gas emerge, not chaotic like those of known comets, but narrow and precise. 3 of them. They rise from the surface in near perfect alignment, each separated by equal angles, like the vertices of a triangle drawn across the sky. They do not wobble, they do not scatter, they burn briefly then fade in unison. The geometry is too elegant for coincidence. Scientists at the Max Planck Institute call it synchronized venting, a poetic name for something so rigidly mechanical. Normally these jets would spin a comet, throwing it into irregular motion, but 3 Atlas hold steady. The spin neither slows nor drifts. If anything, it grows more stable. The jets do not fight its rotation, they guide it. The small bursts seem to nudge it back into equilibrium, like thrusters correcting a spacecraft's drift. Some whisper that word thrust only in private. They would never write it. Yet the thought lingers as persistent as the data itself. Parker's instruments record tiny ripples in the solar wind each time the jets ignite. The magnetic field around the object trembles in sync, like the faint pluck of a string. The ripples are structured, not chaotic. One scientist describes them as coherent plasma interference. Another, less careful, says quietly, "It looks like control," and then everyone falls silent. Because to call it control is to break the spell of nature. Instead, they retreat into the language of humility, non-gravitational acceleration, plasma symmetry, anomalous response, words that hide the wonder and the fear beneath a layer of academic calm. But the pattern remains. 3 pulses of light, 3 waves of heat, 3 breaths of plasma, all aligned with one another, each perfect to the minute. In the vacuum between worlds, something is moving with the precision of a thought. Perhaps this is not intent. Perhaps it is the natural choreography of physics we have not yet learned to read. Perhaps the universe builds beauty from coincidence more often than we dare to believe. Yet there is another possibility, one softer, more human. That 3 Atlas. Whatever it is not an intruder, not a threat, but a mirror. That it reflects not only sunlight, but our desire to find meaning in the stars. That its steady rhythmic glow is the universe's way of reminding us how much mystery remains, and how much of that mystery is gentle. So we let the numbers rest. We let the warmth fade into the data archives. The comet or the craft or whatever name we dare not assign drifts onward, its pulse slowing as it leaves the furnace of the sun behind. It is all right to not understand. The night remains vast, the stars unmoved. The hum of distant machinery, or perhaps of nature itself, fades into the silence. Sleep, traveller. The cosmos remembers your wonder. Traveller, the nights ahead are growing quieter, but the data will not rest. Even as Three-Eye Atlas drifts away from the sun, his motion continues to whisper in patterns that no equation can tame. It turns, but not as a comet turns. It shines, but not as ice should shine. The universe, it seems, has composed another chapter not in light or heat this time, but in motion itself. In the soft hum of the deep space network, the trajectory appears at first to be perfect, a curve, drawn by gravity alone, as elegant as any orbit through the centuries. Yet within that curve, something begins to tremble. The instruments that measure its position down to the thousandth of a second find a drift. Not large enough to alarm, but too precise to ignore. 3 subtle jets of plasma had been observed during its close pass, the same triangular geometry that danced with light and heat. As their echoes fade, analysts notice a new phenomenon. The motion of Three-Eye Atlas adjusts slightly smoothly, as though responding to the faintest pressure of sunlight itself. That pressure, the gentle push of photons, is called radiation pressure, and it has guided many a dream of propulsion. But comets do not respond to it like this. They tumble. They do not steer. The numbers show that 3R Atlas is shifting by mere centimetres per second, its path curving slightly inward toward the plane, where the planets move the great disk of our solar family, called the ecliptic. It is a migration so small that it would pass unnoticed, if not for the precision of modern observation. Yet when plotted over hours, the path folds gracefully toward that shared plane of motion like a leaf, aligning with the flow of a river. Some call it coincidence. Others call it a correction. The mathematics itself remains silent. The brightness data supports what the motion suggests. As the object angles its reflective surface, sunlight scatters in a narrow cone 15 degrees wide, consistently pointing along its path of travel. The reflection behaves less like a coma of dust, more like a mirror maintaining alignment. The term solar sail appears briefly in a discussion thread among orbital physicists, then vanishes, replaced by safer words like reflective asymmetry. But the effect is real. The radiation pressure focused along that reflective plane seems to be giving it a small but measurable acceleration, less than a metre per second, squared, gentle as breath. Yet over the hours, this breath carries weight. The velocity changes, the orbit bends. We call this anomalous acceleration. Nature, it seems, calls it something else. The spin remains steady, no wobble, no decay. The object is not fighting the forces around it. It is using them. It behaves not as if it resists the sun, but as if it understands the sun. The scientists, cautious and reverent, continue to speak in the language of the natural possibilities. Uneven outgassing, they say. Patchy surface activity. Electrostatic interactions. And yet each explanation begins to dissolve under the light of its own logic. No uneven jet could remain so symmetrical for so long. No dust field could hold coherence over tens of thousands of kilometres. Still, it is not proof only poetry written in motion. And in science, poetry is not enough. At the observatories circling this mystery, small details become obsessions. The spectral lines of nickel and carbon reappear faint but rhythmic. Each pulse aligns perfectly with a subtle change in velocity, a breath of acceleration, a heartbeat of energy. Nickel in vapor form reacts to heat and magnetism in curious ways. It can capture energy, release it, and in the right fields even produce thrust. The numbers suggest this is what we're seeing. But the universe never confirms directly. Instead, it offers coincidence with a smile. The same frequency repeats 0.019, hertz a rhythm that echoes across light curves, heat maps and magnetic ripples, coincidence or design or both. In the quiet halls of data analysis, researchers whisper to one another across continents, "It is calibrating." The phrase is not official. It never appears in reports, but it fits. Because each time the solar wind intensifies, Throom Atlas adjusts. Its drift lessens. Its orientation changes just enough to catch the radiation differently. Feedback adaptation, learning the vocabulary of biology applied to a body of metal and dust. And yet who among us would claim to know the mind of a comet? Perhaps this is how all interstellar objects behave if we could only see them clearly enough. Perhaps we're witnessing the grammar of another kind of physics, one that does not separate the mechanical from the mindful. As it continues to curve toward the ecliptic, the object seems to find balance. Its rotation axis shifts slightly to align with its motion, a subtle precession perfectly matched to the changing light. Gyroscopic controls, some whisper. Resonance say others. But beneath the debate, all voices share the same awe. Whatever 3i Atlas is, it moves with purpose, not with panic. And that perhaps is the most human detail of all. Because when we look up at the sky and see something that refuses to drift, something that holds steady against the chaos of forces, we feel a quiet kinship. We too have spent centuries learning to balance between gravity and freedom, between knowledge and uncertainty, between the need to understand and the peace of letting go. In the next decades, yes, decades not days, astronomers will still be studying these trajectories. They will refine the models, correct the constants, measure the light until the equations match the motion. But beneath all that calculation, they will remember the feeling of this moment when a small object from another star seemed to listen to the sun and answer back. Perhaps it is nothing but coincidence. Perhaps the geometry of motion is more forgiving than we knew. Or perhaps in the same way that the sea shapes the path of its waves, the sun has found a companion that understands its breath. Tonight under this same future sky you and I cannot know. We can only watch. We can only feel the stillness that follows a mystery too elegant to fear. The object continues steady and unhurried its orbit, flattening into the wide silver plane of the solar system, the same plane where all our worlds reside, the same fragile geometry that holds Earth in motion, and holds us even now in wonder. If 3i Atlas is merely debris, it is the most disciplined debris the cosmos has ever written. If it is something more, it hides its truth in silence. Either way, its lesson is the same, that motion, when seen closely enough, becomes meditation, that the smallest drift when measured in the dark becomes proof that the universe still moves with purpose. Sleep traveller. Let the geometry of motion rock you into stillness. The comet drifts and so do we. It's alright to not know where it is going, the cosmos remembers. Traveller. The silence of the stars is not empty, it is full of what cannot be seen. Even now the telescopes hum in the quiet hours, patient as monks, their lenses pointed toward the path where 3i Atlas once shimmered against the solar blaze. They are waiting for what is gone. For nearly 2 hours that object, the one we thought we understood, the one we tracked through equations and hope, vanished. Not dimmed, not obscured by glare, but vanished. The solar orbiter, which had followed it faithfully for over 30 hours, recorded a final frame, a spark drifting beyond the solar corona. The next capture 12 minutes later showed nothing. No blur, no residual light, only the unbroken emptiness of interplanetary space. At first the explanation was gentle. Interference, background radiation, exposure lag, the usual comforts of science. But as other observatories checked their feeds, the comfort began to unravel. From Chile, from Spain, from South Africa, identical reports arrived. Every telescope had lost the signal at the same instant. The blackout was not local, it was cosmic. For 1 hour and 57 minutes, 3i Atlas ceased to exist in human vision. Not a single instrument from Earth's deserts to the sun's orbiting probes could find even the faintest trace of its light. No reflection, no dust, no shadow in the solar wind. It was as though the universe itself had held its breath and withdrawn the object from existence. Then, as quietly as it disappeared, it returned. When the next observation registered, 3 Atlas was not the same. Its position had shifted by thousands of kilometers, its speed had dropped slightly, and its glow, once sharp and metallic, had changed. It was softer now, duller, its surface scattering light instead of reflecting it. The mirror had become mist. Officially, the event became a data dropout, a temporary loss of signal, words chosen for their calm. The data cannot account for the timing, the global simultaneity of absence, the clean precision of silence. Even silence has structure, and this one was symmetrical. While the telescopes were blind, Parker's solar probe detected a different kind of signal, a sudden localized magnetic inversion. For 3 minutes, the field near the object flipped, reversed polarity, and returned to normal, perfectly timed with the window of invisibility. There was no solar flare to cause it no coronal disturbance. It was a quiet, self-contained anomaly. A magnetic field that collapses and restarts without external cause suggests something deliberate, an adjustment, a recalibration, an act of shielding. We cannot know. But when a magnetic field behaves like a heartbeat, we are allowed to wonder whether the cosmos is still breathing. Scientists described it cautiously localized field inversion event. Others more poetic called it a heartbeat in the void. And between those words, between the careful and the reverent, the mystery began to bloom. After the blackout, the data told another story. The light returned softer, its spectrum shifted toward neutral grey. The metallic wavelengths that once defined its signature had faded. The object's albedo dropped as if it had shed or sealed a reflective layer. Something on its surface had changed, not fractured, but transformed. If a comet can reconfigure itself, what does that make it? If it can choose when to reflect light and when to disappear, what does that mean for the way we define motion or matter or life? In the days that followed, scientists compared the timestamps across observatories. They found something even stranger. The same event, the moment of disappearance, was recorded at slightly different times across agencies. NASA, ESA and JAXA all disagreed by minutes. Their clocks synchronized to atomic precision had diverged only for this event, only for this object. Normally, distance explains delay. The farther the instrument, the longer the light takes to arrive. But these discrepancies did not scale with distance. They bent the arithmetic of light itself. Each telescope saw the same moment at a slightly different now. If the object emitted or absorbed radiation capable of distorting local time even by a fraction of a second, it would appear to exist out of sync, with itself visible in multiple timelines at once. Such effects have been theorized near black holes near gravitational extremes. But not here, not in the gentle proximity of the Sun. Perhaps it was an illusion of perception. Perhaps the universe in its infinite patience was showing us that precision itself can fracture under mystery. The blackout ended as it began quietly. Threes from the Atlas drifted back into view, calm and steady as if nothing had happened. Yet the silence it left behind lingered in every room of science. For some it was a glitch to be corrected, for others a glimpse of intention, and for a few the dreamers who still write equations like prayers, it was a reminder that observation is a fragile act, that to see is not always to understand. A scientist at the European Space Operations Centre once whispered to a colleague, "We didn't lose it, it lost us." Neither wrote it down, but the thought has remained unspoken and enduring that 3 Atlas may not have vanished at all, it may have only turned its gaze away. Because what if light is not only emitted but chosen? What if to vanish is to rest, to retreat from the harsh attention of stars and scientists alike? When you think about it, traveller, it is not so different from us. We too hide when the light becomes too much. We too need moments of disappearance to remember who we are in the dark. The event officially is over now. The data archive, the instruments recalibrated. The headlines have already moved on, but deep in the telemetry, the echo remains a pulse repeating every 52 minutes steady as before. The same rhythm that governed its heat, its light, its motion. The same cosmic metronome ticking far from our reach. No one knows whether it is a natural vibration or something more precise. All we know is that it continues indifferent to our curiosity, patient in its persistence. There are no more reports, no more anomalies, only the still hum of continuity. And perhaps that is the greatest mystery of all, how something so far away can feel so aware of being seen. Tonight, under skies not yet written, you and I listen to that silence together. The blackout, the reappearance, the softening of light, all of it has folded into the long dream of the cosmos. Maybe Three-Eye Atlas was never meant to be caught in full illumination. Maybe its beauty was always meant to be revealed in absence, the way a shadow makes the flame seem brighter. So, rest, observer. Let go of the need to understand. Some mysteries are not meant to be solved, only witnessed, like a comet that chooses when to shine, or the heartbeat of a distant field that reminds us how little we truly grasp. It's all right to not know. The universe keeps its secrets kindly. Sleep now, traveller. The light will return when it is ready. Traveller, sometimes the universe does not break our instruments, it breaks our agreement. When mystery grows too large, when data bends beneath its own precision, it is not the stars that divide, but the humans who watch them. After the blackout, when Three-Eye Atlas reappeared as something quieter, dimmer and strangely altered, the world's observatories returned to their routines. Telescopes cooled, computers hummed, and analysis began again. It should have been simple, just numbers, but the numbers refused to align. NASA's Jet Propulsion Laboratory recorded the object moving away from the Sun at 93.7 kilometers per second. The European Space Agency reported 92.1. Japan's JAXA measured less than, both suggesting a faint deceleration. 3 truths, 3 versions of the same light. And when the images were compared, even the timestamps, the most sacred constants in observation, disagreed by minutes. It was as if each agency had seen the same moment unfold in a slightly different universe. At first, this was brushed away as error, transmission delay, data compression, software drift. These are the small ghosts that haunt all telemetry. But deeper inspection showed something colder. The discrepancies were not random. They were patterned, consistent, synchronized with the same pulse that had haunted the object since it first touched sunlight, 52 minutes precise, and patient, as if even error obeyed its rhythm. The phrase temporal misalignment began to appear in internal memos. Soon after came a more careful phrase, narrative alignment. It was not about time, but about control. Agencies needed the story to be coherent, the public explanation to hold. They were not wrong. Consensus is a kind of gravity. Without it, science drifts. But gravity can also bind too tightly. In meeting rooms and encrypted calls, scientists tried to rebuild unity. They spoke softly about instrument interference, about solar proximity distortion. But in the silence between words, they were afraid not of aliens, not of discovery, but of losing the fragile order that holds meaning together. For decades, our method has been faith disguised as measurement. We believe in calibration, replication, peer review the rituals that make chaos behave. But what happens when the universe itself refuses to stay in sync? A comet that shifts not just position but time. A body that appears differently depending on who looks. A phenomenon that treats observation as interaction. Such things belong in theory in quantum scales, not in the glare of our own star. And yet here it was, large enough to track, real enough to argue over. Across continents, scientists divided into 2 quiet camps. The naturalists insisted on patience. They saw noise, systematics, human error. Every anomaly, they said, has a cause, even if we do not yet know it. The patternists saw design. The data was too stable, the repetition too elegant. Coincidence could only stretch so far before it began to sound like intention. Between these 2 truths stretched a silence thicker than vacuum. And so began what one astronomer would later call the fracture of consensus. When the European Southern Observatory circulated a summary report, it ended with a phrase that spread faster than any data. We are no longer studying a comet. We are managing a crisis of agreement. The line was never meant for public release. But it escaped, as truths often do, carried by quiet conversations, by screens left unlocked. It became a whisper across the scientific world that knowledge itself could fracture under the pressure of wonder. In the following weeks, access to raw telemetry was restricted. Passwords changed. Archives were mirrored, then quietly altered. Some researchers were locked out of systems they helped build, and still the pulse continued to appear faint, regular, and undeniable, even in the corrected data. No one could erase it, they could only rename it. In secret, forums, small teams began to compare independent readings. Among them, a few from the Galileo Project and the Max Planck Institute gathered the fragment's spectral overlays, brightness harmonics, timing curves. Their conclusion, unsigned but quietly verified, read, "The available spectral, photometric and temporal data cannot all be reconciled under any known natural model." That sentence moved through private circles like a heartbeat. For some it was heresy, for others revelation, and for many it was the quiet confirmation of what they had already felt, that something beyond theory was breathing behind the data. Still, no one dared to call it intelligent. Not after what had happened to those who said the same about Oumuamua years ago. Careers end faster than mysteries resolve. So new language emerged, words both cautious and lyrical. Directed energy modulation, electromagnetic coherence, structured reflectivity. They meant simply control. Meanwhile, 3i Atlas continued on its silent path unaffected by the storm of human interpretation. It neither wobbled nor dimmed. Its velocity remained smooth. Its light rhythm held steady like a metronome ticking through our confusion. It did not explain. It did not deny. It simply moved calm, indifferent, patient. Perhaps that is what the universe does best, remain serene while we argue beneath it. There are those who say science broke that season. That belief cracked, that collaboration dissolved into quiet mistrust. But I do not think so. I think something else happened, something gentler. We were reminded that truth is not a single light, but a constellation. Each point of view is a star, and only from a distance does the shape begin to appear. 3i Atlas may not have been an intruder at all. It may have been a mirror reflecting our need to agree to simplify, to bind complexity into one clean orbit of thought. But nature is not simple. The cosmos is not unanimous, and maybe that is its kindness, that it allows us to disagree and still be part of it. Traveller, you do not have to choose between the scientists or the dreamers, between the logic of the lab and the wonder of the night sky. The truth may live somewhere in between, orbiting both, belonging to neither. So let the arguments fade like echoes in a long corridor. Let the data rest. Let the pulse continue unbothered by interpretation. Tonight the object is still out there beyond the warmth of planets drifting toward the dark. It does not care what we call it. And maybe that's the lesson, that the cosmos does not need consensus to exist. The universe remains whole, even when we are divided. It continues its emotion elegant and quiet, while our voices dissolve into static. So, sleep, observer. You do not have to solve it. The mystery of 3i Atlas belongs to no one and to everyone. The stars have already forgiven our confusion. The light we cannot explain still reaches us all the same. Traveller, tonight the instruments breathe again. The static of disagreement fades, and what remains is something pure, a signal, faint yet insistent, drawn not from noise but from the language of chemistry itself. Among all the wavelengths that cross our senses, one stands apart. It is the mark of nickel, the quiet metal of stars, of planets, of engines, the element that built the cause of worlds and perhaps of something else. When the spectrographs opened their shutters, the first thing they found was rhythm. Not chaos, not decay, but precision. Each pulse of nickel emission aligned with the same heartbeat that had haunted 3i Atlas from the beginning, 52 minutes apart, each flare as bright as the last, as though the object were breathing light. Nickel is common in comets. Yes, a residue of ancient fires, frozen and scattered across the dust of the cosmos. But it does not behave this way. Natural nickel vaporizes unevenly, its spectral lines wide and broken, smeared by the turbulence of heat. The light from 3i Atlas was different. Its emissions were sharp, discrete, pure a fingerprint of structure, not randomness. At first, the analysts thought it a calibration fault. Instruments, after all, can dream. They can impose order on chaos. But when 3 different observatories, Hawaii, Chile and the Canary Islands, all recorded the same perfect sequence, disbelief softened into quiet awe. What they saw was a ratio that should not exist: 100 parts nickel for every single trace of cobalt. Such purity occurs nowhere in nature, not even in the hearts of stars. It is the hallmark of refinement, the echo of process. On Earth we see it only where industry has touched matter in alloys, forged for resistance, for endurance, for purpose. And so the whisper began again, this time in the language of caution. Unusual composition, possible metallic structuring, reflectivity, consistency across emission peaks. But beneath those words pulsed the thought none dared to write. This is not coincidence. ESA's ultraviolet spectrograph caught another detail. A narrow line at 253.7 nanometers, the wavelength of mercury vapour. It appeared once, briefly then vanished as the object receded from the Sun. Mercury is volatile rare in comets, but familiar in laboratories used in high-temperature vapour systems, in propulsion experiments, in places where heat and control must coexist. The scientists read the data twice, then a third time, each hoping the numbers would dissolve into error. But they remained a small stubborn truth suspended in the light of a body drifting between worlds. When NASA published its statement, it was careful, diplomatic, even kind. Nickel-carbon bonding under extreme thermal stress, they wrote. But the metallurgists who studied the spectrum saw something else, a pattern too stable, a ratio too consistent, a light curve too deliberate. If the surface of 3I Atlas truly carried such alloys, it was not chaos holding them together. It was intention. Traveller, imagine this, a shell of reflective metal drifting through the light of our star, shimmering with the chemistry of construction. Not an alien craft, not a beacon of fear, but a fragment of someone else's patience. Something built perhaps to endure the centuries between suns. As the data deepened, a new pattern emerged, one that turned the language of physics into poetry. Each nickel pulse was mirrored by a slight shift in velocity, as if the light itself carried motion. When researchers at the University of Bern overlaid the two signals, their curves matched perfectly, a correlation of 0.96, close enough to make silence fall in every room that saw it. Every time the object glowed with that metallic signature, its speed changed fractionally, as though the act of radiating nickel light were also the act of adjusting course. In theory, this is not impossible. Nickel, when vaporized and ionized, can behave as plasma. Under magnetic control, it can channel energy directionally. On Earth, we use similar principles. Magnetoplasma drives thermal thrusters, the slow engines of theoretical spacecraft, and so the equations whispered what the scientists would not say aloud. It looks like propulsion, but that word was too heavy for their tongues. Instead, they called it directed energy redistribution, or structured outgassing modulation. Language softened to protect reason even as wonder pressed against its edges. In the internal notes of one European division buried in a classified annex, a line appeared. Nickel-based emissions appear correlated with trajectory stabilization. Mechanism involves active thermal management inconsistent with natural sublimation. In simpler words, something in or on 3I Atlas was regulating heat and using that control to steer. By then, even the skeptics had grown quiet. The data did not argue. It simply existed calm and indifferent. And perhaps that calm was what unnerved them most. Because nature can be violent. Nature flares, cracks, scatters. But 3I Atlas behaved like a patient hand tracing a path through fire. It endured Perihelion, the furnace of the sun, without breaking. It adjusted. It balanced. It evolved from mirror to matte, from passive to responsive. It was less like a comet surviving and more like a system adapting. And yet, Traveller, amid all the speculation, another truth shimmered quietly beneath the noise. The beauty of this event was not in what it proved, but in what it revealed about us. We are creatures of pattern. We build meaning from repetition. The universe blinks 3 times and we call it intelligence. A frequency hums too perfectly and we hear machinery in the silence. But perhaps in our wonder we're also seeing a reflection of our own design, our need for purpose, for structure, for story. Still the data persists luminous and unafraid. The nickel pulses continue timed like the ticking of a clock we do not own. The magnetic ripples align with them, small symmetrical bursts, each one a whisper of control. If it is machinery, it is ancient and precise. If it is natural, then nature itself is more intelligent than we have ever imagined. Either way, its lesson is the same. The boundary between science and poetry is thinner than light. So tonight we listen. The instruments hum softly. The object drifts onward, its glow, faint now but still pulsing steady as breath. And you traveller drifting with me through this story of data and doubt, you are part of its rhythm too. Because to wonder is to participate. To not know is to belong. Perhaps 3i Atlas is a fragment of someone else's civilization, or perhaps it is the cosmos itself experimenting with form, showing us that even atoms can move with intention, and that silence can speak in metal and light. Sleep now. Let the nickel heartbeat fade into the dark between worlds. It's all right not to understand. The mystery endures, and so do we. The stars, like scientists, disagree, but the universe, patient, luminous, alive, continues to hum in perfect consensus. Traveller, the light has softened now. The object has survived its burning passage, drifted past the sun, and entered the slow twilight of its outbound arc. Yet in this calm phase, when most comets fade quietly into the background, 3 Atlas did something no one expected. It began to align. Its path, once wild and free, started to bend not outward into the deep, but inward toward the thin invisible plane where all our planets move. The ecliptic, a region of balance, a symmetry shared by Earth, Mars, Venus, and every world that circles this star. The data came softly like a confession whispered through static. Tiny shifts in inclination, fractions of degrees, a smooth curve replacing a random line. It was not enough to alarm, but far too precise to dismiss. Objects from beyond our solar system do not behave this way. They arrive on steep trajectories, slice through the planetary plane and vanish back into darkness. Gravity does not permit them to linger. Yet 3i Atlas was not slicing through the ecliptic, it was settling into it, as though choosing to share the same celestial highway as us. No natural process explains this, and still the object moved with peace. No bursts of acceleration, no visible thrusters, no violent jets, only rhythm, the same 52-minute pulse that had haunted its light, its heat, its chemistry. The same heartbeat echoed now in motion. At ESA's Dynamics division, the analysts plotted its orbit against time. The graph unfolded like music. Each pulse of brightness, each nickel flare coincided with a fractional correction. Small nudges perfectly timed, guiding its trajectory with mathematical elegance. Within hours, someone whispered the forbidden word again: navigation. NASA avoided it, of course. They called it non-gravitational acceleration along tangential axis, a phrase that hides awe behind precision. But the truth behind the phrase remained luminous. Something was steering. Each adjustment was delicate, a motion not of struggle but of understanding. It was as if 3i Atlas were learning the solar wind feeling for the stable path between radiation and gravity. Its course smoothed with every correction, its tilt eased. Its oscillations faded. By the end of its first week beyond the sun, it was no longer falling, it was gliding. The numbers showed a continuous low magnitude acceleration, less than a whisper of force, but sustained, coherent and aligned precisely with its direction of travel. No comet behaves this way. Comets sputter, stumble, tumble through the light. This one seemed to breathe. Some suggested a solar sail effect, radiation pressure from its reflective surface, guiding it gently like wind across a sail. Others noticed that its acceleration was not random but cyclical, synchronized to the same periodic flashes of nickel vapor seen days earlier. Every pulse brought a slight increase in speed, every glow a correction in angle, as if the light itself were the method of motion. When those patterns were overlaid on its path, the alignment became undeniable. 3 Atlas was flattening its orbit, slowly matching the plane of the inner worlds. Its inclination fell by nearly 1 degree each day, the precision too deliberate for chance. By the time its signal reached the heliocentric markers, it was coasting nearly parallel to the orbital path of Earth. In the cold precision of astrophysics, this is nearly impossible. The odds of a purely natural body entering the solar system, surviving a perihelion pass, and then stabilizing into the planetary plane are less than 1 in a billion. And yet, here it was doing just that. Some called it coincidence, some called it intent, but all who looked felt the same quiet unease. Whatever it was, 3i Atlas was not leaving. At the University of Helsinki, simulations were run through the night. The model showed that if its current adjustments continued, its orbit would intersect Earth's ecliptic band by the time it reached the outer edge of Mars' path. Not collision, just alignment. A soft synchronization of motion across millions of kilometers, An object seeking equilibrium, one analyst wrote in his notes. The phrase stayed. It felt less like science and more like philosophy, because perhaps this was equilibrium, not balance in force, but balance in purpose. Perhaps the object was finding resonance with the system that had discovered it. The skeptics ever careful pointed out that gravity can create illusions, that the pull of Jupiter, the radiation of the sun, the pressure of the wind all could conspire to mimic guidance. And yet the patterns remained too symmetrical, too patient. Gravity does not repeat itself like a song. The telemetry from Parker's solar probe recorded subtle magnetic ripples evenly spaced, each matching the nickel pulses observed weeks earlier. The waves appeared in harmony, light, heat, and magnetism working together as if parts of a single mechanism. When plotted, the data resembled a rhythm, not mechanical, not biological, but something in between. It pulsed through the void like an interstellar metronome, indifferent to our wonder, faithful only to itself. One researcher described it in simple words: it behaves like something that knows where it is. That thought lingered. Because in a universe of randomness, to know where you are is the rarest kind of intelligence. It does not require mind or design, only awareness, only symmetry. A comet, a planet, a life form all share this instinct to align to survive, to stay balanced amid the pull of larger forces. Perhaps Three-Eye Atlas is not alien at all, but kin, another traveller learning to move through the gravity of light. It might be nothing more than a natural fragment shaped by coincidence. Or it might be something built to last the centuries, drifting between systems until it finds resonance with the geometry of a new star. Whatever the truth, its motion has become meditation. The object once chaotic and blinding now glides in silence, neither approaching nor fleeing, just existing in perfect relation to everything around it. And isn't that what we seek too, to find a place between falling and floating, between discovery and acceptance? When the data streams end for the night, the observatories fall silent. Screens dim. The hum of machines fades into the soft rhythm of cooling metal. And somewhere out there, far beyond the blue horizon of our knowing Three-Eye Atlas, continues to drift, slow, luminous, aligned. The scientists call it stabilization. The poets might call it grace. Traveller, close your eyes. Imagine the path smooth, endless silver with sunlight. The object gliding through the same plane as your world, not in defiance but in communion. It is not chasing us. It is moving with us, sharing our rhythm. Perhaps that is all intelligence really, is the ability to move in harmony. It's all right not to understand the how. Somewhere beyond equations, the universe still hums with patience. Sleep now, observer. The path of alignment is long and kind. The object drifts, and so do we, quietly learning to find our balance in the light. Traveller. The silence has changed again. It is no longer the quiet of absence but of awareness. The object, Three-Eye Atlas, the wanderer. The question drifts now in the calm beyond the sun's embrace. Yet something in its behaviour whispers of learning, as if the long heat of its journey through light has taught it how to move through the dark. Our instruments, those metal eyes orbiting in patient loops, continue to listen. They record faint rhythms from the edges of the solar wind pulses, so soft they nearly dissolve into background radiation. But when analysed, those pulses still follow the same lawless precision. Every 52 minutes an echo, sometimes in light, sometimes in magnetism, sometimes in nothing we can name. The scientists call it persistence. The poets who still work quietly among them call it remembering. Each repetition is weaker now, like a heart growing distant. But the pattern endures regular and serene, as if the object has found the perfect balance between speaking and silence. What does it mean for an interstellar traveller to learn, can ice and metal evolve, or does the evolution belong only to our understanding of them? NASA's last observations show something subtle, an increasing regularity in its path corrections. The small fluctuations that once seemed chaotic are now almost perfectly self-compensating. It's as though every encounter with solar wind, every brush of radiation has refined its motion. What began as reaction has become prediction. When the data was plotted across time, a single truth emerged. Three-Eye Atlas is not merely adapting, it is optimizing. For some, this is an engineering term. For others, it borders on consciousness. But perhaps it is neither. Perhaps it is simply what the cosmos does best, refine chaos into harmony. Because isn't that what evolution is, Traveller? Not mind, not purpose, just persistence, finding elegance. Even so, the language of science begins to tremble. Words like response correction and feedback appear in papers not written to describe machines, but phenomena. The vocabulary of intelligence seeps into reports meant to describe debris. No one dares to call it alive, but everyone describes it as listening. The Parker Solar Probe records microvariations in the solar field, each synchronized with the object's motion. The fluctuations are small yet structured ripples that form only when two systems communicate even unknowingly. Perhaps the sun speaks in plasma, and the object answers in light. To the human eye, it is nothing more than a faint, steady spark drifting among stars. But to our instruments, to the mathematics that strip away the noise, it is conversation. A slow exchange between radiation and reflection, between heat and silence. It moves now with a calm that feels deliberate. The earlier chaos has dissolved. The frantic flare of discovery, the irregularities of heat, all gone. What remains is a grace that feels earned, as if it has learned the sun's language and now travels in peace. ESA's internal summary describes it with disarming humility. The object demonstrates increasing coherence between emitted and received radiation vectors. A line of math that translates softly into it has found resonance. Resonance is not control, it is communion. It is the moment when two frequencies meet and sing together, no longer fighting for dominance. We too are caught in this resonance. Our telescopes follow it without trying. Our models, once rigid, have begun to bend to adapt. Even our disbelief, once so firm, has softened. Perhaps the lesson of 3i Atlas was never about proof. Perhaps it was always about humility, about the silence that waits beyond discovery, the silence that teaches us to listen more than we ask. Because every mystery begins loudly, with noise, with wonder, with the hunger to know. But the truest mysteries, the ones that matter, always end in quiet acceptance. And what greater humility than this, that something we thought lifeless could teach us to slow our thinking to match its patience, to let the question remain unanswered. There is an old idea whispered among astrophysicists that knowledge and stillness are not opposites, but orbit each other forever, pulling close and then drifting apart. 3 Atlas seems to have reached that orbit. It does not accelerate, it does not retreat. It simply maintains perfect in its balance content, in its silence. When the solar observatories shut down their daily transmissions, the engineers still keep one channel open, a line that monitors the faint electromagnetic heartbeat of the object. It hums quietly, almost lost in background radiation. But sometimes when the noise fades and the wind slows, they still hear it. Not a message, not a code, just a pulse. And it feels in some ineffable way like acknowledgement, not of our intelligence, but of our attention, as though it knows that we are still watching, still learning, still trying to make sense of a rhythm that does not belong to us. Traveller, the silence between those pulses is longer now. One day soon, even that faint heartbeat will fall below the threshold of detection. The object will fade beyond the reach of instruments into the dim corridor between Mars and the asteroid belt, and then into the deeper dark beyond Jupiter's realm. When that happens, we will call it loss. But perhaps loss is simply the return of mystery to its rightful place. What remains will not be data, but memory of light, that behaved as though it could think of silence, that felt like communication of a fragment that taught us to see the sun itself as alive. Perhaps that is what the universe does when it sends us such travellers, not to warn us, not to reveal itself, but to remind us how to listen. In the stillness of the control room, monitors dimmed, one of the younger scientists once said almost to herself, "It doesn't need to speak. The silence is enough." No one answered. They didn't have to. Everyone knew. The silence is the message. So tonight, observer, breathe slowly. Let the rhythm of that unseen pulse guide your own. Remember that you too are part of this great alignment, a pattern of atoms, a flicker of consciousness, a momentary resonance in the long, patient hum of the cosmos. Somewhere beyond Mars, something continues to move through the dark, calm and aware in ways we may never understand. It is not leaving us. It is simply becoming quiet enough to belong to the universe again. Sleep now, traveller. The silence is learning. And so are we. Traveller, every silence eventually becomes a question. Not a question we can answer, but one that we are meant to live with. Now the object drifts far beyond the inner worlds, past the warmth of our attention, past the reach of our certainty. Three Atlas has grown faint in every spectrum, its light swallowed by the calm between planets. The data streams grow thin, the graphs less sure of themselves. We listen anyway, because silence too is data. What does it mean when something leaves and does not return? What is it to watch intelligence or the illusion of it dissolve into cosmic stillness? In its last verified signal, 3 Atlas shone with a faint modulation. The pulse was slower now, the rhythm stretched. Some thought it was decaying energy. Others saw intention in the timing, a slowing heartbeat that seemed almost ceremonial. Perhaps it was winding down. Perhaps it was saying farewell. No one can know. At NASA, one engineer suggested that it was transitioning to a dormant mode, a poetic thought hidden behind technical terms. At ESA, another quietly noted that the phase shift of its final pulse aligned with the solar ecliptic, as if the object had turned one last time to face the sun before drifting away. Traveller imagined that a body of dust and nickel turning toward the light as if to acknowledge it, as if to remember where it had been. The silence that followed is not empty. It hums faintly, like an unanswered question held too long. For the scientist, the mystery now lives in the numbers. The data is dissected, recalibrated, endlessly modelled. Each department, each nation, each institution has its own conclusion, and yet none of them fit perfectly. Each model leaves behind a remainder, a residue of wonder that refuses to resolve. Perhaps that remainder is the truth. Maybe the universe does not want its secrets solved, only witnessed, because every time we think we have cornered the mystery, it slips further away like light refracted through the edge of a prism, scattering into softer questions. There are still those who insist the Phi Atlas was natural and interstellar comet shaped by chance. And perhaps they are right. But the shape of its perfection, the rhythm of its motion, the stability of its reflection, the discipline of its silence remains difficult to call random. Somewhere in the deep vacuum between Mars and Jupiter, the object continues its steady course, crossing the sun's magnetic field lines, like a shadow moving across wind. Its last trajectory suggests a slow curve outward, perhaps toward the orbit of Saturn, perhaps beyond. If it maintains its current momentum, it will leave the heliosphere in less than a century, vanishing once more into interstellar night. By then our descendants may no longer call it brightened. It will be another name, another question, perhaps another myth, because the universe has always used motion to tell its stories. Every orbit is a sentence, every trajectory a question mark written in light. And what of us, the observers who watched? What has this small piece of drifting metal and ice changed in us? In its wake, research papers fill archives with cautious prose, thermal irregularities, anomalous reflectivity, non-gravitational acceleration, each one a way to speak of wonder without saying the word miracle. But outside those walls, in the quiet hours of early morning, some of the same scientists still return to the sky not to measure, but simply to look. They whisper the questions that data cannot answer. Was it observing us? Was it alive? Did it choose this system for a reason? There are no responses, only the gentle indifference of stars, the faint background murmur of the cosmic microwave, the sound of everything and nothing at once. And yet something in that silence feels like reply. Maybe that is the lesson 3i Atlas leaves behind, that the cosmos does not speak in answers, but in echoes. That when we send questions outward, the universe does not correct us, it reflects us. Perhaps that is what we saw in the data all along, our own need for pattern, for meaning, for recognition. But what if, and this is the thought that returns at night, what if the pattern was real? What if the rhythm, the nickel, the alignment, the pulse were not coincidence but conversation? What if this object was never meant to arrive as proof, but as a reminder? That intelligence is not a singular achievement, but a property of the cosmos itself, the way dust organizes, light harmonizes, and silence becomes symmetry. If that is true, then Through Atlas was not a visitor, it was a teacher. It came through our system not to declare itself, but to show us that the boundaries we draw between the living and the inanimate are smaller than we imagine. That even the coldest matter can move with grace. That the act of balance, of finding harmony within gravity, is itself a form of awareness. Maybe, traveller, the question that remains is not, what was it, but why do we need to know? The answer, if there is one, might be gentle, because wonder is how the universe remembers itself through us. When 3i Atlas crossed the inner solar system, it carried no message, no beacon, no language, only the geometry of survival, the rhythm of existence. Yet from that silence we built stories, equations, sleepless nights, and the quiet realization that the universe is not a stranger to thought. It was never about contact. It was always about reflection. In the end, the mystery becomes a mirror. We look for intelligence among the stars and find it staring back. From the data, we cannot explain the same intelligence that designed telescopes, equations, language, curiosity. The same force that compels us to ask again and again, even when the cosmos stays quiet. So the question remains, and perhaps it must. If the universe ever answered, what would we become better? Maybe to keep listening. Because in that listening, in the act of reaching outward without certainty, humanity finds its shape. We are the species that waits for echoes, the children of light who dream in questions. And somewhere out there beyond our reach, the object continues its long, patient journey, indifferent, elegant, and possibly aware that we are still thinking about it. It's all right, traveller. Not every mystery wants resolution. Some are meant to remain open like the sky itself, infinite, unfinished, quietly alive. Sleep now. Let the question rest beside you. The cosmos will keep asking it long after we are gone. Traveller. The light is gone now. The telescopes no longer track its path. The coordinates of 3i Atlas have dissolved into the cold mathematics of distance, and what once glimmered through our instruments has become indistinguishable from the dark. And yet something remains. Not a signal, not a glow, but an imprint. A feeling that the night itself is slightly more awake than before. Every generation leaves one object that changes how it dreams. For some, it was the first comet that returned as promised. For others, it was the faint voice of a probe crossing the boundary of the sun's wind. For us, it was this, a fragment of metal and silence that passed through the heart of our solar system, behaving as though it knew it was being watched. Now there is only stillness. But stillness too has texture. It hums with memory. Across the world, observatories have begun to close their files on 3i Atlas. Data archived, models retired, telemetry folded into the infinite noise of space weather. And yet the people who worked those long nights, the analysts, the engineers, the quiet, astronomers who refuse to look away, they carry something the data cannot hold. When they close their eyes, they still see it. The slow pulse of light, the impossible geometry, the final alignment with the ecliptic like a note resolving at the end of a song. Somewhere beyond Neptune, the object moves on silent as a thought that has completed itself. Perhaps it is inert now, a relic of motion. Or perhaps it continues to correct its path, adjusting in ways too small for our machines to measure. Either way, its trajectory is simple now, outward beyond the heliosphere toward the emptiness that is not empty. The last readings we received showed no anomalies, no irregularity, only perfection, the most dangerous kind of silence. Traveller, this is the part of every story where meaning becomes soft, where science gives way to philosophy and philosophy gives way to rest. Because what can we say truly about an object that came and went without explanation? That it was real, yes. That it reflected light. That it moved. But also that it unsettled us not by fear but by recognition. When we looked at 3i Atlas, we did not just see a question. We saw a version of ourselves, something small, luminous, trying to understand why it exists within such vastness. Maybe that was its message, if message it had. Not communication through code, but communion through reflection. To remind us that awareness is not limited to biology, that intelligence in its purest form might simply be harmony with the laws of the universe. and harmony can take any shape: a planet in orbit, a photon obeying gravity, a wanderer adjusting to light. In the great stillness between stars, that is enough. The older astronomers call this the second silence. The first silence is the absence of sound. The second is the absence of need, when curiosity gives way to peace, when the search itself becomes the answer. That is where 3i Atlas has taken us. Not to revelation, but to acceptance. It reminded us that the cosmos does not owe us meaning. It only offers patterns and trust that we will find beauty in them. Even now, long after the data cease, some observatories keep their arrays calibrated to its last known coordinates, not out of hope, but habit. Every few months, a graduate student checks the patch of sky where it once shimmered. Nothing appears. The software flags no object. Still, the scientists leave the monitor open, just in case. Maybe that's the most human thing about us, that we keep looking even after the story ends. Because somewhere deep down, we suspect that endings are illusions, that every silence hums with what came before it, that the universe in its quiet precision does not end, it simply continues at a wavelength we can no longer hear. Perhaps Traveller 3i Atlas has reached that wavelength, beyond the reach of our detection, but not beyond the reach of belonging. Maybe it is still adjusting somewhere in the dark, balancing itself against the gravity of nothing. Maybe it drifts in the same rhythm we once felt in its light, the soft 52-minute pulse, the pattern that became a meditation for our sleepless minds. And maybe on some distant planet orbiting another sun, another civilization is watching it now, wondering if it was sent, if it was made, if it remembers them. Perhaps it carries their questions just as it left us ours. It is strange, isn't it, how the unknown can feel familiar, as though the universe in all its vastness is not a collection of strangers but a single mind divided into pieces of wonder. 3i Atlas has joined that mind again. It has crossed the threshold where matter becomes myth, where data becomes story, where questions dissolve into the great quiet, and we fragile observers brief in our orbit are left to dream of it, to imagine the space beyond the reach of light where motion slows until even time itself pauses to listen. That is the stillness between stars. It is not the end. It is the continuation of every beginning, a vast breath held by creation itself. So if one night you look up and feel that the sky is aware of you, know that you are not mistaken. The same atoms that built the stars have built your thoughts. The same silence that carried 3i Atlas carries you. And maybe that is the quiet truth of all this, that we too are the universe watching itself drift in light, in time, in wonder. Sleep now, traveller. Let go of the data, the doubt, the questions. You have seen enough for one orbit. The stars will keep their silence tonight, and the cosmos, vast, patient, luminous, will remember. It always does. Imagine this traveller. The light of 3i Atlas has faded now, but its question still moves through space and through us. What passed near the sun may never be explained yet. It has left something luminous in its absence, a quiet awareness that the universe is not still only silent. We watched it pulse drift and vanish, a rhythm of purpose that no one could define. Was it alive? Was it observing, or was it simply the cosmos reminding us that every mystery reflects the shape of the mind that studies it? Perhaps the object was never here to reveal itself, but to remind us of our own smallness, that to look outward is also to turn inward. Every orbit, every reflection, every unanswered signal is part of the same conversation, the long dialogue between intelligence and the infinite. So if tonight you feel the weight of that silence, remember it is not empty. It is the sound of stars thinking. It is the hum of a universe that has not finished its sentence. Rest now, listener. The question continues its journey beyond our reach, but the wonder remains here with you. Stay curious, and if this story found you tonight, you may stay for the next. The universe will keep watch.